Welcome to Unacademy Ascend YouTube channel. This is Umamaheswara Rao. Tomorrow I'll be starting a new course on Engineering Mathematics for GATE 2022. Course starts from 1st January, timing 6 p.m. to 8 p.m. I am coming up with a new course, practice course on Engineering Mathematics for Engineering Sciences, exclusively for Engineering Sciences for GATE 2021. Course starts from 1st January, timings 8:30 to 10. In 2 months crash course on Engineering Mathematics for GATE 2021. Today I will be discussing probability and statistics, PYQs of probability and statistics. Let me start. First problem, the probability that a number selected at random between 100 and 999 both are inclusive will not contain the digit 7 is. Will not contain the digit 7 is. Will not contain the digit 7. You have to form a 3-digit number. Given that a number is selected at random between 100 to 999, between 100 to 999, the total number of integers between 100 to 999 is 900 numbers. So in that 900 numbers, we have to find out no digit contain the digit 7. So in a 3-digit number, this place neither 0 nor 7, neither 0 nor 7. So remaining entries you can fill from 0 to 9, total 10 digits. In that 10 digits, neither 0 nor 7. So total 8. So remaining 8 digits you can fill. So here you can take 0 but not 7. That's why 9 numbers. Here you can take 0 but not 7. 9. So here not 7. Here not 7. Remaining all digits you can fill. Right? So total number of possible ways are 8 into 9 into 9. 9 9 is 81. 81 into 8. 648. So favorable cases equal to 648. Total number of possible ways (100 to 999), 900 numbers. Therefore, the required probability is 648 by 900. By simplifying this, we get 18 by 25. 18 by 25. Now, next column. 7 car accidents occurred in a week. What is the probability that they all occurred on the same day? 7 car accidents occurred in a week. What is the probability that they all occurred on the same day? In this problem, first accident can occur any day of the week. So how many possibilities you have? 7 ways. Either Sunday or Monday or Tuesday or Wednesday or Thursday or Friday or Saturday, right? So 7 possibilities. What about second accident? Second accident can occur any day of the week. So 7 ways. Like that, 7th accident can occur any day of the week. Therefore, 7 ways. Now, total number of possible ways are seven into 7 times, therefore 7 power 7. Now, we have to calculate favorable cases. What are favorable cases in this problem? All these 7 accidents, they all occurred on the same day. They all occurred on the same day means all these accidents occur on the same day means either Monday or Tuesday or Wednesday or Thursday or Friday or Saturday or Sunday. That's why favorable cases are either Sunday or Monday or Tuesday or Wednesday or Thursday or Friday or Saturday. So 7 ways. Therefore, the required probability is number of favorable cases are 7, total number of possible ways are 7 power 7. The required probability is 1 by 7 power 6. Understood? Next problem. A box contains chips numbered 3, 6, 9, 12, 15. Box 2 contains chips numbered 11, 6, 16, 21, 26. 2 chips, 1 from each box. This is the keyword. 2 chips are drawn, but 1 from each box are drawn at random. The numbers on these chips are multiplied. The probability that the product is an even number. 3, 6, 9, 12, 15. 6, 11, 16. 21, 26. Now, observe here. 2 chips are selected, one from each box. One chip is drawn from box 1, another chip is drawn from box 2. The numbers on the chips are multiplied. The probability that product is even number. Now, we have to select one chip from box 1, one chip from box 2. We have to calculate the probability that product is even number. When product will be even number? If you select even number from box 1, even number from box 2, or even number from box 1, odd number from box 2, or odd number from box 1, even number from box 2. Observe here. Even number from box 1. 2 even numbers are there. You are going to select one even number. So 2C1. Even number from box 2. 3C1. R means plus. Even number from box 1. 2C1. Odd number from box 2. 2C1. R means plus. Odd number from box 1. 3C1. Even number from box 2. 3C1. Simplifying this, numerator is 2 3 is 6 plus 4 plus 9 by 5 5 is 25. That is 19 by 25. Correct answer is 19 by 25. Next problem. What is the probability that a divisor of 10 power 99 is a multiple of 10 power 96? A divisor of 10 power 99 is a multiple of 10 power 96. So, total number of possible cases are divisors of 10 power 99. Observe here. 10 power 99 can be written as 2 into 5 whole power 99. That is 2 power 99 into 5 power 99. So I have written 10 in the form of 2 prime factors. The reason is we have direct formula. You can calculate total number of divisors very easily with the help of that formula. If you write the given number in the form of product of 2 prime numbers. So here 2 and 5 are prime numbers. Therefore, I have written 10 in the form of 2 into 5 power 99. So the total number of divisors are given by 99 plus 1 into 99 plus 1, this power plus 1 into this power plus 1. So 100 into 100, that is nothing but 10,000 divisors. So the total number of divisors of 10 power 99 are the total number of divisors of 10 power 99 are 10,000. Now, among these 10,000 divisors, we have to identify how many divisors are multiples of 10 power 96. Observe here. Ten power 96 into 1, 10 power 96. 10 power 96 into 2, 10 power 96. 10 power 96 into 3, 10 power 96 into 2, 10 power 96 into 3, like that. 10 power 96 into 4. These are all multiples of 10 power 96. 10 power 96 into 1000 equal to 10 power 99. So we have to identify 1, 2, 3, 4 till 1000. So here 1000 multiples are there between 10 power 96 into 10 power 99. These are all multiples of 10 power 96. Sir, after 10 power 99 also you have multiples of 10 power 96. Yes, we have, but we are not interested, because in these 1000 multiples, how many multiples are divisors of 10 power 99? We have to identify. Those are the favorable cases, right? Now, observe here. 10 power 99 by 10 power 96 into 1 can be written as 10 power 96 into 1000 by 10 power 96 into 1. Here 10 power 96 cancel. Yeah, 1 divides 1000 or not? 1 divides 1000. Therefore, this multiple divides 10 power 99. 10 power 96 into 2 is also divides 10 power 99. 10 power 96 into 3 not divides 10 power 99. 10 power 96 into 4 divides 10 power 99. Like that we have to check. To verify like that, it consumes time. That's why what I am doing, I am calculating divisors of 1000. How many divisors of 1000 you have? That number of divisors are multiples of 10 power 96 which are divides 10 power 99. That's why I am calculating among these 1000 multiples, how many multiples are divisors of 1000. I am just verifying. Observe here, same logic. 1000 can be written as product of two prime factors. 1000 can be written as 2 cube into 5 cube. 2 5 is 10, 10 cube is 1000. Now, I have written product of two prime factors. That's why the number of favorable cases equal to, power 3. Here power 3. So 3 plus 1 into 3 plus 1. that is 16. So among these 1000 multiples of 10 power 96, 16 multiples are dividing 10 power 99. So among these 1000 multiples of 10 power 96, only 16 multiples are divisors of 10 power 99. Therefore, the required probability is 16 by 10,000. 16 by 10,000 is nothing but 1 by 625. So correct answer is 1 by 625. Next column. The probability that student knows the correct answer to a multiple choice question is 2/3. If the student does not know the answer, then the student guesses the answer. The probability of the guessed answer being correct is 1 by 4. Given that a student has answered the question correctly, the conditional probability that student knows the correct answer is, observe the problem, given that the student has answered the question correctly. If the student has answered the question correctly, then the probability that the student knows the correct answer is, it is a problem designed on Bayes theorem. Student knows the answer and guesses the answer. Both are mutually exclusive events. Your sample space is covered by two mutually exclusive events. Knows the answer, guesses the answer. Generally, if the student does not know the answer, then only the student guesses the answer. The probability that student knows the answer is 2/3. Therefore, automatically the probability that the student guesses the answer is 1/3. Answer correct is an arbitrary event. If the student knows the correct answer, if the student knows the answer, it is 100% correct. If the student guesses the answer, the guess being correct is given by 1 by 4. Therefore, 1 by 4. It means that there are 4 options. Among the 4 options, one option is correct. That's why whose chance is 1 by 4. Whenever student guesses the answer, the guess being correct is 1 by 4. If the student knows the answer, that is 100% correct. We have to find out if the student has answered the question correctly, what is the probability that student knows the answer? If the student has answered the question correctly, then the probability that the student knows the answer, observe, knows the answer, outer value 2/3 into inner value 1. So 2 by 3 into 1 by 2 by 3 into 1 plus 1 by 3 into 1 by 4. By simplifying this, we get 2 by 3, LCM 12, 3 4 j 4 2 j 8 plus 1 9, 9 by 12. 2 by 3 into 12 by 9, that is 8 by 9. So correct answer is 8 by 9. Next problem. An automobile client contracted to buy shock absorbers from two suppliers X and Y. X supplies 60% and Y supplies 40% of the shock absorbers. All the shock absorbers are subjected to a quality test. The ones that pass the quality test are considered as reliable. Of X shock absorbers, 96% are reliable. Of Y shock absorbers, 72% are reliable. X supplies 60%, in which 96% are reliable. Y supplies 40%, in which 72% are reliable. The probability that randomly selected shock absorber found reliable is made by Y. So it is also a problem on Bayes theorem. X supplies 60% of the shock absorbers. Y supplies 40% of the shock absorbers. Reliability is an arbitrary event. 96% of the shock absorbers supplied by X are reliable. 72% of the shock absorbers supplied by Y are found reliable. Randomly a shock absorber is selected and found reliable. What is the chance that it is supplied by Y? So Y, so outer value 40%, inner value 72%. 40% multiplied with 72% by 60% into 96% plus 40% into 72%. By simplifying this, we'll get 0.334. Correct answer is 0.334. Observe this problem. The chance that a student passing in an exam is 20%. Student passing in an exam is 20%. The chance that student passing in the exam and getting above 90% is 5%. Given that a student passes the examination, what is the probability that the student gets above 90%? So it is a problem on conditional probability. So here, if you define event A is student passes the examination. B be the event that student gets above 90%. Now we have to find out, if the student passes the examination, what is the chance that student gets above 90%? So B by A. Probability of B intersection A by probability of A. Probability of B intersection A is nothing but 5%. probability of A is 20%. Simplifying this, 5% by 20% is 1 by 4. That is 25%. So answer is 1 by 4. Next column. Candidates were asked to come and interview with 3 pens each: black, blue, green and red. Black, blue, green, red were permitted pen colors that the candidate could bring. The probability that candidate comes with all 3 pens of same color. Candidate comes with all 3 pens of same color. The permitted pen colors are black, blue, green, red. Black, blue, green, red. Now, first I am writing total number of possible ways. So here, total number of possible ways means the candidate could bring all 3 pens of same color, or all 3 pens of different color, or 2 of same color and 1 is of different color. These are the 3 different possible ways. Now, in all 3 pens of same color, total number of possible ways are 4, because all 3 pens may be black or blue or green or red. 4 different colors are available. That's why all 3 pens of same color can be black or blue or green or red. 4 ways. Now, all 3 pens of different colors. From 4 colors, you can select 3 colors. Now, 2 of same color and 1 is of different color. Here, I am using simple logic. 4 colors are available. 4 colors are available. In that 4 colors, you select 2 colors. 4C2. Within the 2 colors, you select 1 extra pen. 2C1. From 4 colors, you select 2 colors. 4C2 ways. So within the 2 colors, you select 1 color extra. Within the 2 colors, you select 1 color extra. Then 4C2 into 2C1. Now 4 ways, 4 ways, 4C2 is 6, 2C1 is 2. That is 4 plus 4 plus 12. Total number of possible ways are 20 ways. Now, favorable cases. Favorable cases. What are favorable cases? Favorable cases are nothing but all 3 pens of same color. all 3 pens of same color. There are 4 colors are available. That's why 4 ways. The required probability is 4 by 20, 1 by 5, 0.2. It is a numerical data type problem. Answer is 0.2. Next problem. P and Q are considering to apply for a job. The probability that P apply for the job is 1 by 4. Probability that P apply for the job given that Q apply for the job is 1 by 2. The probability that Q apply for the job given that P apply for the job is 1 by 3. The probability that P does not apply for the job given that Q does not apply for the job is 2017 GATE problem. Now observe here, completely the problem is designed on conditional probability. Probability of P is 1 by 4. Probability of P is 1 by 4. Probability of Q by P is 1 by 3. Probability of Q by P is 1 by 3. So probability of Q intersection P by probability of P is 1 by 3. Probability of Q intersection P by 1 by 4 equal to 1 by 3. Probability of Q intersection P is 1 by 3 into 1 by 4, that is 1 by 12. Probability of P intersection Q is 1 by 12. Probability of P is 1 by 4. Next, probability of P by Q is 1 by 2. P intersection Q by probability of Q is 1 by 2. 1 by 12 by probability of Q is 1 by 2. Continuation. 1 by 12 by 1 by 2. Probability of Q is 2 by 12, 1 by 6. Now we can find out probability of P union Q equal to probability of P plus probability of Q minus probability of P intersection Q. Probability of P is 1 by 4. Probability of Q is 1 by 6. Probability of P intersection Q is 1 by 12. That is 4 by 12, 1 by 3. Now we have to find out probability of P does not apply for the job given that Q does not apply. P dash intersection Q dash by probability of Q dash. P union Q whole dash by probability of Q dash. That is nothing but 1 minus 1 by 3 by 1 minus 1 by 6. that is 2 by 3 by 5 by 6. 2 by 3 into 6 by 5, 4 by 5. So the answer is 4 by 5. Next column. There are two identical locks with two identical keys. The keys are among 6 different ones, which a person carries in his pocket. In hurry he drops one key somewhere. The probability that the locks can still open by drawing one key at random. There are two identical locks with two identical keys. The keys are among 6 different ones. So total number of keys are 6, in which 4 are different, 2 are identical. In hurry, he drops one key somewhere. That key could be identical or could be different. Chance of losing identical key is 2 by 6. Chance of losing different key is 4 by 6. Suppose identical key is lost, then the remaining number of keys are 4 different and 1 identical. If different key is lost, then 3 different and 2 identical are left. Finally, you have to find out the locks still opened by drawing one key at random. The locks are identical locks. You have to open that identical locks with identical key. That's why you have to draw identical key to open the lock. So chance of getting identical lock 1 by 5. A chance of getting identical key 1 by 5. Here chance of getting identical key 2 by 5. Now 2 by 6 multiplied with 1 by 5. This is probability of losing identical key and probability of opening identical lock. This is probability of losing different key. This is probability of opening identical lock. 4 by 6 multiplied with 2 by 5. This is 2 by 30. This is 8 by 30. You can open the lock either by this way or by this way. That's why either 2 by 30 or 8 by 30 means 2 by 30 plus 8 by 30. That's why 10 by 30. So 1 by 3. The required probability is 1 by 3. Understood? Next column. A coin is tossed, a dice is rolled larger number of times. The mean value of the outcomes is, a dice is rolled larger number of times, then mean value of the outcomes is, if a dice is rolled, possible outcomes are 1, 2, 3, 4, 5, 6. Corresponding probabilities are 1 by 6, 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 1 by 6. Therefore, mean value of the outcomes means mean of outcomes is given by sigma x into p of x. Mean of the outcomes is nothing but expectation. That's why expected value of the outcomes, that is 1 into 1 by 6, 2 into 1 by 6, 3 into 1 by 6, 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. That is 1 by 6 of 1 plus 2 plus 3 plus 4 plus 5 plus 6. 21 by 6. That is nothing but 3.5. So correct answer is 3.5. In this problem, an examination paper has 150 multiple choice questions of 1 mark each with 4 options. Each incorrect answer fetches minus 0.25 marks. Suppose 1000 students attended the examination, they answer all the questions randomly, the sum of total of their expected marks obtained by the students is. So here all 1000 students are attended the examination and they have selected the options randomly. Then what are their total expected marks? Now first you have to prepare probability distribution table, marks and corresponding probability. If the student answers the question correctly, he will gain 1 mark. If the student answers incorrectly, he will lose 0.25. That's why probability of getting correct answer is 1 by 4, because they have selected the options among 4 options. Therefore 1 by 4. Incorrect is 3 by 4. Now expected marks per 1 question. Expected marks per 1 question. Sigma x into p of x minus 0.25 into 3 by 4 plus 1 into 1 by 4. This is nothing but minus 3 by 16 plus 1 by 4. One by 16. Now per 1 question 1 by 16 marks. Total 150 questions. Therefore 150 into 1 by 16. That is 150 into 1 by 16, 9.375 marks per 1 student. So total 1000 students attended the examination. All the students are selected the answers randomly. That's why the sum of the total of their expected marks. That's why for 1000 students, 1000 multiplied with 9.375, that is 9375 marks. Sum of the total of their expected marks is 9375. So correct answer is 9375. A random variable takes values 0, 1, 2, 3 with probabilities 2 plus 5p by 5, 1 plus 3p by 5, 1.5 plus 2p by 5 respectively. Then the value of P and E of X are, X takes values 1, 2, 3 with the probabilities 1 plus 2 plus 5P by 5, 1 plus 3P by 5, 1.5 plus 2P by 5. Now we have to find P value. Sum of all probability mass functions equal to 1. So 2 plus 5P by 5 plus 1 plus 3P by 5 plus 1.5 plus 2P by 5 equal to 1. 4.5 plus 10P equal to 5. 10P equal to 0.5. P is equal to 0.05. The value of P is 0.05. Next, expectation of X, E of X, sigma X into P of X. 1 multiplied with 2 plus 5P by 5, 2 multiplied with 1 plus 3P by 5, 3 multiplied with 1.5 plus 2P by 5, that is 2 plus 5P, 2 plus 6P, 4.5 plus 6P by 5, that is 17P plus 8.5 by 5, that is 17 into 0.05 plus 8.5 by 5, that is 1.87. So E of X is 1.87, the value of P is 0.05, 0.05 and 1.87 is the correct option. First option is correct. Next problem. Each of the 9 words in a sentence, the quick brown fox jumps over the lazy dog, is written on a separate piece of paper. These 9 pieces are kept in a box. One of the pieces is drawn at random from the box. Then the expected length of the word drawn is. The quick brown fox jumps over the lazy dog. Each word of the sentence is written on a separate piece of paper. Here length of the word represents number of letters in that word. Okay. Now here first word, how many letters are there? 3. Here 5. Here 5. Here 3. Here 5. Here 4. Here 3. Here 4. Here 3. So length of the word 3, 4, 5. Corresponding probability. Yeah, how many words are there with length 3? Total 9 words are there, in which one, 2, 3, 4. 4 out of 9 with length 3. 2 out of 9 with length 4. 3 out of 9 with length 5. Now the expected value of length, E of length, equal to 3 into 4 by 9, 4 into 2 by 9, 5 into 3 by 9. Simplifying this, 12 plus 8, 20, 20 plus 15, 35 by 9. That is 3.88. Right? 3.88. Yeah, in this problem, in a manufacturing plant, the probability of making a defective bolt is 0.1. What is mean and standard deviation of a total of 900 bolts respectively? So here, probability of defective bolt is P. Probability of defective bolt is 0.1. Number of bolts are 900. We have to find mean. Binomial mean is NP. So 900 into 0.1, that is 90. If P is known, you can calculate Q value. If P is 0.1, Q value 0.9, because sum of probability of success plus failure is always 1, right? So if P is 0.1, then Q will be 0.9. Now, variance. Binomial variance is given by NPQ. N value 900, P value 0.1, Q value 0.9. Multiply 81. Variance is 81. Therefore, standard deviation is square root of variance. That's why square root of 81, that is 9. So correct answer is mean is 90, standard deviation is 9. Mean is 90, standard deviation is 9. Next column. An unbiased coin is tossed infinite number of times. What is the probability that fourth head appears at the 10th toss? 10th toss. Fourth head appears at the 10th toss. Tenth toss, you have to get head. When it will be called as fourth head? In the previous 9 trials, if you get exactly 3 heads, then whatever head you are going to get in 10th toss, that head will be fourth head. So probability of getting 3 heads in 9 trials, probability of getting 3 heads in 9 trials, NC3 P power 3 Q power n minus 3 multiplied with head. So here 9C3 1 by 2 whole power 3, 1 by 2 whole power 9 minus 3 multiplied with probability of getting head is 1 by 2. That is 9C3 by 2 power 10. That is 84 by 1024. That is 0.082. Correct answer is 0.082. Next column. The number of accidents occurring in a plant in a month follows Poisson distribution with mean 5.2, then the probability of occurrence of less than 2 accidents in the plant during a randomly selected month is. So here random variable follows Poisson distribution with mean 5.2. X counts number of accidents. We have to find out probability of X less than 2 accidents. So probability of X equal to 0, probability of X equal to 1. Here X follows Poisson distribution, therefore e power minus lambda into lambda power x by x factorial. Here x value 0, that's why e power minus lambda into lambda power 0 by 0 factorial. Here x value 1, that's why e power minus lambda into lambda power 1 by 1 factorial. By taking e power minus lambda common, 1 plus lambda, that is e power minus 5.2 of 1 plus 5.2. (6.2) into e power minus 5.2, that is 0.034. So correct answer is 0.034. Thank you.